deliver session on the title Solar, Wind, Hydel Power Generation Technologies as a Thermal Energy and Utility System. Dr. P V Ramana sir is presently working as a professor Mechanical Engineering Department as well as working as a Dean R&D, Head of Aeronautical Engineering Department with the Sardar Vallabhbhai Patel Institute of Technology, SVIT Vasad. He holds a PhD and MTech in Mechanical Engineering with a specialization in heat transfer and thermal power from Indian Institute of Technology, Madras, Chennai. He earned his BE in Mechanical Engineering from BVM College of Engineering, SP University, Vallabhbhai. He had about 10 years of industrial and R&D experience in the field of renewable energy before joining the teaching profession. During his 25 years of teaching experience at SVIT Vasad, he has taught several UGPG courses in the mechanical engineering, particularly thermal steam courses. He has over 61 research papers published and presented in international journals and conferences to his credit. He is principal investigator of Gujarat funded research project on the coating and its erosion characteristics on boiler steels and also work as co-investigator into DST New Delhi funded research project during his tenure at Pureri, Vallabhbhai. He is also working as a reviewer for several national and international conferences and peer-reviewed journals. His major areas of specialization are thermal systems, heat transfer, CFD, energy, renewable, eligible bath, thermohydraulics in porous media. He contributed 2 book chapters to Springer Lecture Note series, Advances in Smart Grid and Renewable Technology. He holds life membership in many professional societies like Indian Society for Technical Education, IST, Indian Society for Heat and Mass Transfer, ISHMT, etc. He is also guiding several research scholars for their doctoral degree at GTU, Ahmedabad, CVM University, Vallabhbhai, CU Shah University, Vadhavan, Charu Set, Changa. He has a technology patent on natural draft gasifier system to his trading. So it is our very luck that sir provide his valuable time for empowering us with the recent development in the solar wind power generation technologies to our participants participated from all over India. Welcome, sir.
Thank you very much. Am I audible properly? My voice is audible to you?
Yes, sir. Your PPT is visible and you are audible. Please make your PPT a full screen so that in larger form it will be available.
Yeah, just I made it full. Yeah, it is already there.
No,
is it all right?
Still it's smaller. You have to press this cup button at the bottom, sir. So that's why it is then of a full screen. Or press F5. It's automatically on pressing F5.
Yeah, but in my system it is showing full only.
Sir, during the sharing of the screen, you can set as a share whole screen instead of a window PPT.
Yes, sir.
Yeah, whole screen is shared.
Whole screen.
We have only the, not in PowerPoint mode it is showing, it is only in a Windows mode it is showing us.
Yeah, just I will share it.
Yes, sir.
Now also same problem.
Okay, no problem. You can continue, sir.
Just a minute, Dr. Jani. सर आपको 68% दिखता है वहाँ पे बाजू में आपके बॉटम की स्क्रीन पे 68% लिखा हुआ है?
एक्चुअल में मैंने क्या है डेस्कटॉप से प्रेजेंटेशन कर रहा हूँ।
कोई बात नहीं सर, आपका जो स्क्रीन है ना डॉक्टर साहब, आपका जो स्क्रीन है वहाँ पे 68% नीचे दिखता है, बराबर? तो उसके बाजू में जो सिंबल है ना उसको आप क्लिक कर लीजिए खाली। ये परसेंटेज वाला नहीं, उसके बाजू में।
परसेंटेज के बाजू में सर।
Yeah, that's only I am doing. That I did already.
नहीं, वो नहीं सर, वो बात नहीं।
नहीं समझ गया।
बस वही।
Yes, वो कर दिया है, फिर भी ये प्रॉब्लम है ऐसा है. Now it is okay? I don't know.
Now it is enlarged, sir. Enlarged.
Enlarged, that is because of zooming actually.
Yes, yes, this is because of zooming. So keep that 88% to 100% and then present the full screen, so that is available in PowerPoint mode. Sir, what you have to do, you have to share the screen as a wall screen. During sharing,
yes, full screen.
Okay. So that your wall computer screen will be afterwards you see full screen, then the same thing will be available to participants.
Now?
Now it is okay, sir. You can continue now.
Is it visible?
Yes, sir. Visible as well as your voice is also audible, sir.
But it's not turned up to full screen. Okay.
Some percentage will get missing here. F5. If you press F5, then what happens, sir? Please confirm. F5.
आप रिक्वेस्ट कंट्रोल में कि आप मुझे कंट्रोल 1-2 मिनट के लिए कंट्रोल दे सकते हैं?
Yeah. Okay, any solution? Is it visible now? But
It is
not
visible now.
screen,
You can continue. You can continue.
Okay, at the outset, thank you very much, Dr. Jani sir, for the nice introduction. And also, I welcome all the participants for this particular FDP, those who are attending the current field practices and energy and utility systems since 6th of this month and 6th to 10th. And I congratulate the organizers, the coordinators and conveners and patrons of this event getting happened. So very, very good, and I congratulate them for these efforts, for their efforts. Also, the success of this particular event. And today we all gathered here for the completion of this particular ATAL FDP, current field practices for energy and utility systems. So in this sense, I would like to put up the case what I am professing since long, related to the solar, wind, and hybrid power generation technologies, because the solar and wind are the renewable energy sources, as all of us know. So this is the sort of slide change now for all of you.
Oh, no, sir. Slide is not getting changed.
Okay.
Same slide is presented here now.
So I have logged in as 2 persons. So both are same or what? So that's why there is.
So 2 login will be there, sir. One Dr. P V Ramana as a guest, and both are due as a guest. So from same system you have logged in two ways, sir?
Yeah. And then one is from mobile. I have logged in.
Mobile, so there is no problem. Another account is getting its microphone off. So you can present it with the mobile too, sir. So there is no problem by logged in by the two accounts.
Yeah, but this problem, no, display problem is there still.
Yes, sir. Display problem. What, sir?
Yes, sir. Yes, sir.
Can we do from here anything so that sir can?
Here we have a perfect, but there is a issue regarding sharing of the screen. So there are two options are coming when you share the screen. One is a whole computer screen and another is the only the windows which are open on the desktops or taskbar. So in which Microsoft PPTs you have shared, it will be not in a running mode when you are sharing.
Yeah, but here for me only option is showed that no entire full screen like that.
Sorry to interrupt.
Yes, sir.
सर फर्स्ट ऑफ ऑल आप स्क्रीन को पहले शेयर करना बंद कर दीजिए, मतलब रिमूव दैट प्रेजेंटेशन वाला रिमूव कर दीजिए पहले. गो टू द ओके नाउ नो प्रेजेंटेशन, करेक्ट. नाउ आपका जो पीपीटी है उसको वो आपका प्रेजेंटेशन व्यू में चले जाइए. प्रेजेंटेशन व्यू यू कैन सी. आर यू एबल टू सी द फुल स्क्रीन नाउ? पीपीटी फुल स्क्रीन.
1 minute.
आपका जो पीपीटी है उसमें वो प्रेजेंटेशन में जाइए, जो नीचे में आपको दिखाई देगा.
बटन F5 दबाया है तो.
हाँ, स्लाइड शो में गए. अभी आप टीम में आ जाइए. नाउ गो टू द
प्रेजेंट करो.
हाँ, टीम में प्रेजेंट कीजिए. ओपन स्प्रे वो जो है ना उसमें देखिए नीचे जो रहेगा देयर आर डिफरेंट स्क्रीन. उसमें से जो स्लाइड शो वाला स्क्रीन है ना वो आप प्रेजेंट कीजिए. उसको सिलेक्ट कीजिए.
Now it looks like okay.
Yeah.
Thanks. Yeah, that is what.
Yes. Okay.
Initially. Yeah, now it's perfectly operating.
As a full screen, sir. Screen is available as a full screen. Now no problem, sir.
Yeah, it is available. Only thing is whether slides are changing or not. That we have to check. Okay. So okay, next slide I will go.
Your voice is also audible and screen is full screen mode now. It is okay, sir.
Yeah, now slide is also changing. So let us start our thing. So today we are going to talk about this electricity generation related aspects, because that is what the relevant topic, the field practices of particular utility systems and all. And in this, how we are going to fit this particular renewable energy, as my topic suggests, the solar and wind hybriding, and also we will be talking about some storaging, and because of what it leads to another technology that is known as the hydrogen fueling system, hydrogen fuel cell system. And these are the aspects basically briefly I will be going to discuss here. And as to run through these slides regarding to this renewable energy, that is the conventional and non-conventional earlier people used to talk about, and once upon a time which is conventional, now it has become non-conventional, and the other way around. So similarly, that's why the terminology now ministry also using as a new and renewable energy sources. Okay, renewable is the more appropriate word for this type of thing. Solar, hydro, and wind, and all other renewable technologies what we are talking about. Okay. So in this sense, we'll be having solar and wind as the renewable energy sources here, and so that is the abundant source, the sun, and similarly the hydro, water cycle also there, and windmills. These are the because of these fossil fuels and depletion and pollution problems, as all of us know. So gradually we are shifting to the renewable energy sources, non-conventional energy sources, what we talk about. And the solar is the major one, as all of us know. So it is replacing almost the installed capacity as we want to increase. Now the government and our private sector. So people are preferring to go for the solar PV. And similarly, the domestic level also, all these are, we are all aware that now rooftop solar PV plants we are going to all these will be reducing or mitigating our problem of electricity generation for the country. As you know, at present we almost have like 350,000 megawatt of installed capacity in India, but it is not sufficient as the growth rate, the GDP is going at 7% growth rate. So we have to increase it very much high. So for increasing these things, so one of the helping hand now we got is the solar PV. Very quickly you can install and bring it into working when you compare with the regular or conventional thermal power plants, coal-based thermal power plants or gas turbine power plants, etc. So in that sense, we'll be preferring this. And they both are having their own advantages and disadvantages, all of us know. And if we see that renewable energy, we have abundant of that type of energy is there, which can be harnessed for electricity as well as heating applications also. The sun and wind and water, these are the major things. And list also we will see what are the other things are there. Whether it is all around us and it's free, these are the advantages sun, wind, when we are talking about. On the top of that, it never goes to run out. That's why we call it as renewable and does not need to burn. So there won't be any CO2 emissions or it won't create any pollution basically. And there are several types of renewable energies, but the focus majorly on solar energy, and that too solar energy itself, again, there is two parts, as you know, photovoltaics and thermal. So out of that, thermal is okay, but photovoltaics we are reliable, rely more on that particular photovoltaic technology, and now it is become very handy. So even if somebody wants to have a rooftop solar plant, so very quickly you can have this particular thing, and within a week's time you can get it installed, and you will start exporting the electricity to the grid. So that type of developments happen, and also the initial cost, etc. In the beginning of this particular technology, when it is picking up, the cost component was very high, and now it is also reduced drastically. So that's why we have the per unit cost of electricity generation. Now it is competing with the coal-based thermal power plants, even less than those things. So that also we will see what is the cost factor we'll have. And solar energy and wind power and hydro, one of these things. And others are there, presence are there, but tapping those things are a little tedious, and also it is also not that economical to do that. And but by force, as the electric vehicles are picking up, so because of that, the hydrogen and fuel cell technology is there. So we have to link these things to solar and wind or excess power which is available for us. By using that, can we produce hydrogen and run the fuel cell based EV cars? Okay. At present, what we are seeing in the market is the EV cars based on the battery system, battery charging stations and all are required, and that we can shift it as to the hydrogen fueled fuel cells, which will be requiring to fill up the like CNG gas and all. So we have to have a hydrogen cylinder, and which can be filled up at recharge stations, and it will be going running. So in place of batteries, the fuel cells will be there, and which will be providing the electricity required to run that particular vehicle of electric based EV. So these are all small portions of these energies also getting tapped, but there are not much noticeable thing is happening, and the solar and wind are in a big way. It is going on. Onshore is there up to now, and offshore also people are exploring at present. And if you see the figures of these, installed capacity of India, mostly coal-based, almost like 57 to 60% is there. You see, So now this point of time, no, it is slowly reducing. This growth is not there. It is stable and it is reducing because the renewables are picking up a little bit, and government has also given the emphasis related to this particular thing. The install capacity needs to increase the current levels of 344 gigawatts. Okay, that is 3,44,000 megawatts, which is there to 562. It is required to go up as the country is growing. No, that is one of the indication of if you consuming more energy and per capita, suppose, then it will be going to be a developing country. So per capita energy consumptions in India, if you see, that means per person per year, how many units of electricity equivalent they are consuming. Okay, whether it is petrol or diesel or electricity or anything, all the total energies if you consider. No, so the what is the quantum of units you are consuming? So that depends. No, so the country's growth rate you can tell. So similarly, typically, if I say it will be like 1,500 to 2,000 in India, we have so per capita energy consumption, whereas those values will be like 15,000 to 20,000 in US and other developed countries. Okay? So one of the reason you can put it to this is there are all coal countries where the electricity consumption is very high because to some extent because of the weather conditions there, always they will be running heaters in their homes and all. So that may be there, but even though a lot of industrialization is there, so because of what the electricity consumption is much more high. So if you divide that, and also the other thing is the population is very, very small here when compared to this. So when you per capita, when you calculate, these values will be bigger. But even though as of now, 10 times difference, which is showing literally by the values like 1,500 to 15,000. But basically maybe less than that. But even though we have to grow up more, like 15,000 if you want to go to three times more. So a lot of installed capacity has to be increased and a lot of industrialization is required and yes to consume. So gradually it will go 2050 or so, like no. So it crosses 1,000 more than 1,000 gigawatts. Okay. So that is the scenario. The authority is quoting these things. Now we have, that's why to reach those values and targets which are posed upon here by the electricity authority. So now the government has given a target of so this is the another scenario. That is what in the previous slide I showed you the renewable energy contribution about 20%. So the bifurcation of that is given here: small hydro, wind, solar, and if you see these things out of this, as I told you, the wind and solar is the major portion. Earlier of this decade, the wind was picking up maximum potential is tapped, and now the solar is picking up because earlier the solar costing was more. Now the problem is solved, and now a lot of manufacturers, Indian manufacturers, are available, and also a lot of panels are available from China and other cheaper costs. And because of this, more and more solar power plants are installed. A lot of private parties also coming up into setting up 2,000 or 5,000 megawatt solar power plants. Yeah, because of the government's power purchase agreements, PPA facility is there. And also the solar power plant gestation period, like installation time is also very small compared to the thermal power plants, and also it will be working on a very reliable basis. Only thing is, it is only daytime we can able to get these things, and this much of large energy which is produced through solar, you have to utilize it, otherwise we cannot store these things. So that is another problem with this. And these are the values at present. That means around 20 gigawatt you will be producing solar. These are the things up to 18. So now, because of this, the energy consumptions are also increasing plan by plan. So So the distribution also you can see domestic, agriculture, and industrial. Industrial is the major thing. After that, the agriculture is there, and T&D losses. People are working a lot to reduce those losses. That will be also a plus point for all of us. And domestic also will be going to reduce because everybody is now putting up rooftop things, and similarly the LED lamps replacement also going on. So compared to the previous consumption, now the domestic consumption also will be gradually reducing, in a sense. It may not be reducing, but we are also having the alternate ways of meeting that particular thing. So that's why overall load on the installed capacity of India, so it will be reducing. That burden will be reduced, and whatever is installed capacity will increase. So that you can easily divert it for the agriculture and industrial. These are the major things. Okay, our country's prime thing is the agriculture and industrial. So these things will be picking up, and that means enough energy supply will be there to these consumers. Similarly, that's why the push to renewables is given. As I told you, the gestation period advantage is there. Quickly, if you want to meet the targets of building up enough capacity, installed capacity. So that's why, suppose the government has given the target of 2022. So 1,000 gigawatt of solar and 60 gigawatt of wind energy. So now the solar is around at 18, it was around 25 gigawatt. And now we have to shoot up like anything. So because of this, lot of private players like Adani, Tata, and all, so they are also setting up the power plants, and that also will be add up with these capacities. And even though we are very way behind of this particular target at present, and as you know, because of this announcement, that time they have initiated initially about 20,000 megawatts in our Gujarat or Kutch area, and also some land allocation is also done. The work is going on, and so that's how we have to go through this, and we have to try to achieve this 100 gigawatt. So that what happens is, so that 344, which is there at present in 2018 figures. So if you increase it by 100, that means it will become 450 or so. We'll be nearing to the requirement which is there for 2030, as such, like 500 and 550 or 560 gigawatts. So that we should be able to achieve. So that way, the solar PV is very helpful for us in picking up these targets and achieving these targets. Okay? And next one is the green energy corridors. 5.6 billion is there, and similarly 33 solar parks in 20 states are envisaged, and some of them are getting realized. Okay. And next, the typical example to observe the growth of renewables is capacity addition in 2016 and 17. This is, for example, if you take to compare. So conventional energy sources in those periods, it was increased by 14,000 megawatts only, and added up the capacity addition. And similarly, the renewable sources, that means whether it is solar or wind or whatever it is, so that was around 14,000. So almost it was like equal to each other. Okay. Earlier, before the 16, 17 and previous years, if you see, so these renewable sources were very small contribution used to be there, and but there is a drastic jump in 2016, 17. Conventional sources increased by 5.6%, but renewable sources increased by 33.6%. So that much of jump is there, and solar witnesses 81.7% growth in capacity addition between 2016 to 17. Okay. So growth in capacity addition for wind remained as it is 20% for 16, 17 also. Okay. So that is, there is no much change. And so per capita electricity consumption, if you see, as I told you, 1,500, I have a little bit higher side, I told you 15. But it is around 22 units, 1670. Okay, so that is the situation for us. Similarly, the installed capacity power systems, RES as well as conventional EPC, gradually they are increasing. And towards this side, 18, 19, 20, if you see, so the curve will be more steeper compared to the conventional power installation. Because suppose source-wise installations also, if you see solar and wind, if you see, so wind is also there earlier period, and now the solar will be steeply going to increase. So the renewable energy minimum target for 12-year plan, that is reaching a 13.5 plan. As I told you, the gigawatts, 10 gigawatt was the target in the earlier, and now it is increased to 100 gigawatt. So that is what the government has envisaged the potential of solar power, and easily we can set up these power plants. The target of this, that's why they have fixed it to 100 gigawatt solar and 60 gigawatt wind energy. So if you see these figures, these values, if you see, and these values, what very ambitiously government has fixed up. So can we able to reach there? That is also doubt, but at least 50% of that we are going to meet. That is what the present developments and the most of the parties taking interest in these particular installations. Captive power plants and private and public partnerships. Trying to put more and more investment in solar PV and trying to increase the installed capacity of the country. So this is the potential, basically, in megawatt per phase, if you could able to extract these things. So the wind is also the potential we have. If you go offshore also, so maybe increase for more and more potential. So these are all the similar things, and very big potentials are there, but lacking of technology and determination. We are not exploring these things. Wherever it is very cost effective, people will be trying to do that. When there is no go, then you have to try to explore the VOTEC also. And similarly, the target solar energy year-wise target is given by the MNR, Ministry of New Energy. Solar targets, rooftop as well as ground-mounted solar plants. So these are all add up. Similarly, because of these initiatives, the country ranking, renewable energy country attractive interest ranking. So India also reached to 4th rank, 5th rank in the wind energy. So this will also give you the development, what is happening, it is encouraging. And similarly, if you see these things, the sum of these energy cost, leverage cost for energy production, 1 unit of energy, if you want to produce, what is the cost going to be incurred for us? So if you see earlier, so it was very, coal is always very low, but comparatively, now it is going to increase a little bit. And similarly, the wind is also nominal. So that's why these technologies were very much used. And whereas solar PV drastically changed its scale, and now it is reduced to almost 2.5 to 3 rupees like that. But rooftop, it is just a little costlier, 4.5 to 5 rupees. But the large installations in megawatt size plant, the production calculate, so it will be almost like so 2.5 to 3 rupees it will come. So that is very compatible now with the conventional energy production, electricity production. So that's why a lot of emphasis has been given to this particular solar energy. And similarly, what are the present scenario we have? So if I am talking about the hybriding of the solar and wind, and whatever electricity is produced, to be able to store it in terms of hydrogen and use it through fuel cell route. So will it be going to gain anything? Because ultimately we have to see at the thermodynamic, the overall efficiency of the system also, the electrical efficiency, what we are putting in and what we are going to get out of this. And if you compare with these technologies, the fuel cell is always ahead of these present technologies. What we have, even combined cycle gas turbine and thermal power plants, with the steam turbine, Rankine cycle based. Similarly, diesel engine and spark engines, as you already know, they will be always less than these things. And that's why one of the promising case when we want to go through this particular EV, fuel cell based EV, we want to. And similarly for electrical generation also, stationary fuel cell stations, if you keep and supplying the hydrogen and oxygen, so continuously you will be going to get the electricity. So that is one of the advantages you have to keep in mind about the fuel cell. And the solar energy potential, but all of us know that a lot of potential is there, and it will be translated and tapped. Then you will be able to easily get the 100 gigawatt of target, which is fixed up by the government at least by 2024 or 25. Otherwise, it's not there. So these are the solar thermal power plants. As I told you in the cost also, I showed solar thermal power plants will be a little bit of higher costing there. And also the technology is also not of that established and very much ease of maintenance there compared to the solar PV. So that's why the solar thermal is not picked up so well. But this is also one of the mature technology we have, because it sometimes is required to be operated. And similarly, this is the layout of this particular type of power plant. Solar collectors, truck collectors you can have and circulate the feed water into this, and then it will be going into these particular superheaters, vaporizers, and then it will be working, expansion work in the turbine. So this is all normal Rankine cycle you will have. Only thing is the input instead of coal, you are going to put it as from the solar. So, but only thing is the temperatures what we are going to achieve in these things will be less, up to the 350 and 350 degrees centigrade, very high value if I am quoting. So that much of the feasibility is there. So in that range, so these are all the solar trough collectors in the field, but people are also working on this in a big way. So this is also we can produce the electricity through the thermal power plant route. Only thing is the input what we are going to give is it is a pollution-free solar energy. So these are the another type of arrangement. The stats will be there and all will be focused onto the tower. At the top of that, the top of the tower, the boiler is there, and there the steam will be produced by receiving these reflections from all these heliostats, and it will get the so it will be getting operated. So when you see the, first of all, we are talking about thermal technology. PV, all of us know. Okay, so that also we see how to hybrid it. And similarly, the solar thermal ones we discussed about solar trough collectors, parabolic and tower type and dish type. These are three varieties we have. And according to the scales, you can typically from the field experiences, people have given design experiences. People have mentioned these are the scaling sizes you can think about. You have a huge parabolic trough collector field. You have the field practices, these things, utility means in the sense the feed water heating, etc. also is possible. By that way, also a lot of people are trying it in the existing power plants where the feed water heating can be done by solar. So at least up to 10 to 15% of energy can be saved. So that much of coal can be saved, and coal need not to be burned. So that's why that much of pollution creation you can stop, carbon credits and all. So that is another way of doing it. And these are the ranges one can think about. going for this type of solar thermal based power plants for electricity generation. And solar PV farm, it is almost like mature technology. People are working. Only thing is, it will go on increasing if you have a better solar PV cells. They are present at the most 15 and 20%. Then that you will be getting the efficiencies. And but here the efficiency doesn't matter much because we are not spending anything on the running cost or fuel cost, if you say. So that is one thing. So that's why it is picking up the lot. Then we have so here also just state-wise to just mention some of these values from the method of data. So Gujarat was one of the leading country state installed capacity solar basically, but still it is now increasing and front runner. But some of the states like Rajasthan and Andhra Pradesh, they are taking the lead, surpassing the Gujarat. That is what happening. But again, because of this recent announcement of Kutch power plant, etc., again now Gujarat will be a front runner for us as far as the solar is concerned. Okay. Are you getting my noise? The voice? Sorry.
Yes, sir. Voice is clear.
This is okay. 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 So this is about the solar PV we are talking about. Then we also talk about the about solar wind farm also, and then we will try to club it together and aggregate. What are the other storage methods we will discuss in a few minutes. And the wind farm also you have seen. Megawatt, 1 megawatt windmill, a single plant, single one is almost like earlier it was having 250 kilowatt and 500 and later on now. One point even people are making scaling up to 5 megawatt plants also. So, but as of now in India we have most of the things of 500 kilowatt or half megawatt and 1 megawatt windmills. A lot of places is installed. Okay. So this type of similar view will be having wherever the wind farm is there, a lot of windmills will be present there at a particular distances, which will be maintained, and then the setup for exporting these things to the grid. Okay. So here the catch is you don't have any battery storage or something like that. Okay. So it will be continuously fed to the grid whenever it is generated. And there can be also, I told you, in abroad, people are trying a lot of offshore wind farms. And here also, it is very expensive for the installation point of view. That's why people have not yet ventured into this. These things later on. And residential wind systems and net metering. Okay. Similarly, in some of these windmills which are modified and designed for low wind speed operations, which will be like terrace, etc. If you install these things, the blade angle attack, the angle of attack, etc. will be different in this compared to the other regular windmills what you have seen in the previous pictures. Okay. So if you put these things like solar PV and this is the wind turbine here it is showing. If you replace this particular thing like with solar PV, so this kind of system will be working as our rooftop at present what we are talking about. So the net metering concept also you all of you know, whatever you feed into the grid and whatever you use from the grid, the net value you will be displayed and that much of billing will be done. Okay. So that type of concept also the project is already in place. And similarly, whenever you want to have the more and more wind electricity is to be generated continuously, etc. If you see such of the locations near to the apartments, between two apartments or towers, two towers are there, such places appropriate design has to be done and you have to install this type of plants, and there will be a possibility of continuously generation, and it can be powering those particular apartments, etc. To some extent, maybe that type of possibility. And similarly, another misnomer is there, misconception. The impact of info noise. People are using a lot of people. It is very near to the residential. A lot of noise will be there and all these things. So, the people of General Electric, they have also surveyed these things, and they have come across so these things. If it is 500 meters away from this particular residential area, if you see, even our refrigerator, which is there near to us, because it is always inside the house, so it is also creating almost like a 40 decibel of noise. When it is far away, when you are very near here, then it will be not 5 decibels, but far away will be getting the noise as good as this window AC or refrigerator. So that's why there is not much of requirement right now. Thinking about the windmills will be very, very disturbing or something like that. That conception, because of these particular tests, we have proved it. Wind turbines in residential areas are placed no closer than 300 meters from the nearest house. So that much of distance, if you follow like 300, if not 300, if you go for 500, so that's okay. So that's why the small windmills, what I'm talking about on the roof, they will also not going to make much noise. These are all megawatt size commercial windmills, what we are talking about. And similarly, the wind farms, another problem is that, no, so when wind farms are there, then wildlife, a lot of people, a lot of birds and all will be killed, etc. So that is there. So for every 1,000 birds killed by human activities, less than one is caused by a wind turbine. So there is a survey which is from the data, it says that. So almost, suppose in 10,000 birds, only one bird will be because of wind turbine. So it is not a wind farm is not a harm for us. Useful for production of energy, electricity. So, but the problem is why we have to club these things is the wind energy is available when wind is blowing, and similarly solar energy is available when the sun is shining. And these two things are little opposite in the sense day and night they occupy. So the sun will be in the day, and wind still it will be there in night also. Night it will be a little better compared to the day, depending upon the location also it takes place. Because of that, if you have the combination of these two things, then there are chances of having a little bit of continuity, consistency in power generation can be there. So that's why one can think about this type of combination here. In a household, completely want to be free from grid electricity, then you can have a sufficient capacity of PV modules and the wind turbine if you have. This wind solar hybrid controller and inverter if you provide. And some battery bank also you can provide for the emergency purposes. Yeah. So then you will have the AC and DC loading will be, that is basically whatever load it is there. No? Accordingly, the inverter will be working to convert these things into AC or DC according to the load requirements. That is one of the things where people can think at a small scale, as similarly it can be extended to the bigger scales. Next, also the similar setup in the other way of representation. The data collection also will be there, so that we can also, at research level, we should be able to have the system which will be give you the data of the wind generation, what are the times available, solar generation, and what is the quantity. We have to balance these things, and what type of battery, how much capacity battery you want to have. So this case to case, there should be a design software which can be by feeding all these data, so it will be able to produce you. And for the household, what is the load and how much can be the excess. These things you can predict basically beforehand. And similarly for street light combinations also sometimes type of so that fully the battery can be charged even though the sun goes off in the evening. So this windmill also will be going to provide and replenish the battery of the street light. And most of the street light schemes, the subsidy schemes you might have seen by government of India, and those things only the pole will be there and no battery making problems will be there, and after 1 or 2 years of running, it goes off. So all the solar street lights are mostly non-functional. You observe these. Want to make it functional, you should have good battery. Similarly, the hybridization of the solar and wind required. Similarly, for household purposes and small industries also, you can have this type of solar PV and windmill combination. And now we'll be talking about the solar-based and hydrogen generation, which will be given for the hydrogen generation, and then it will be through fuel cell route you can able to run this particular thing. Here you can have the solar and wind hybridization is there, and continuously it will be working. And whatever electricity is going to be generated, at daytime or for the domestic applications, you will be using it to some extent. And remaining time, the electricity will be going to produce. Okay, the daytime, suppose if you don't want to use anything, but even the solar cells will be producing electricity. You have to store that energy. So storing, you have to have a big battery bank is required, and batteries are a lot of maintenance intensive they are, and that's why people want to able to store it batteries. That's why the grid feeding is going to happen. Sometimes the grid is also not there available. So when grid is not live, you cannot able to export the energy what you are going to get. So that time also the solar PV will be producing electricity. Windmill is also producing electricity. So where that electricity? So this type of opportunities one has to identify, and we have to think about a system which can generate the hydrogen. Because hydrogen, one of the method we know is the electrolysis process. Electrolysis process is a very, very simple and very established technology where you can separate out the hydrogen from water. So that can be used as a fuel. It can be stored. Okay. A lot of difficulties are there how to get the hydrogen if this is not the thing, because this electrolysis process is little costly and it won't work out like that. Okay. Per kg of hydrogen, the costing required will be very, very high. A lot of electricity you have to spend on that. So that thermodynamically, you cannot say that whatever you are spending, you are going to get back. So, but whatever spending you are, so that if it is free, so then whatever you are getting is all yours. That is the hydrogen ultimately you are going to get. You can compress it and put it in a cylinder, and that can be utilized at a later stage by the route of fuels. This is what the idea is, and already people abroad and a lot of places, already people are working, and now a lot of car companies also coming up. This is initially for domestic electricity applications people are using, and buses they are running on this, and nowadays the car manufacturers, automotive industry also coming up with these things. Already a lot of research has gone into this, and so only thing is this hydrogen-based EV vehicles can be run. Only thing is where from we get the hydrogen. So that is the thing. So with very less cost, we can produce the hydrogen by using these renewable sources already are established and there. And so this way of production of hydrogen will be completely pollution free. Okay. The EV's case, all of you know that now we will discuss, suppose. So EV, you are running that by electricity. That is very good. Localized pollution free, you can make it. But where from you are going to get the electricity? Ultimately, we are supplying the electricity from the thermal power plants or any other fossil fuel based power plants, suppose. So then ultimately, what is going to happen is pollution, only segregation of it is concentrated in certain areas where the power generation is taking place, and it is not there in the cities and towns where you implement the EV mobility systems, etc. If that also you want to avoid this complete zero pollution thing, then you should be able to identify the methods for producing electricity without pollution. Okay? Without pollution, the electricity we can produce the one way is through the solar cells, okay, and windmill. There are other technologies also, but these what we are talking on today's context. So these are the two things, but the only problem with these two technologies is they are not continuous producers of electricity. They will be very intermittent and they will be very random behavior will be there. And these things we have to tap and you have to store. Okay? There are different methods for storing this electricity which is generated. So one method is to be simply charging the batteries. Okay? How you can charge the batteries and how you will maintain those things. What is the life of the battery? Maintenance of the batteries, all these things are looking not very economical when you want to go for the battery banks. And that's why there is another way of doing it is converting that from the established methods into hydrogen. Also, we have to explore the methods for different types of methods how to produce hydrogen. That is also there. But here the simplest route is whatever electricity available without pollution, without cost, that can be utilized for hydrogen generation, and you can easily store it. And whenever you want it, hydrogen and oxygen you send it to fuel cell, and you can produce the electricity, and you can use that. Okay. Similarly, these fuel cells are also there, different types. The table also I will show you. This is another type of simply a representative diagram for a fuel cell. If you have like this fuel cell, and some of the fuel cells are while doing this particular supplying the hydrogen, oxygen, or any other fuel and oxygen when you are supplying. So they will be working on this fuel cells, but they will be generating a lot of heat while generating this. So that heat also again can be taken and by using some afterburner, you can raise the temperature and pressure of those things and you can run a gas turbine. So this type of fuel cell and gas turbine power generation is also possible by hybriding. How the fuel cell will be running? Fuel cell will be running by hydrogen or any methane gas, etc. So these are different cells will be working for a combination of cells. So what are the different types of cells we'll see next slide. So like that you can have a combined systems also. Okay. Similarly, in our normal conventional power plants, all of you are aware in mechanical engineering, you know the combined cycle systems we can think about to have a better efficiencies. Okay. Gas turbine as well as steam turbine, Rankine and Brayton cycles combined. Then now a little bit about the fuel cells. It is a very old technology. Nothing to mention here much because all of you are aware of these things. And if you see this particular fuel cell, the simplest fuel cell which works as an input as hydrogen and oxygen, if you send it to anode and cathode side, so there will be electron flow will take place and the unused oxygen will come out here and there will be water which is coming out of the particular system. And here the heat generation will be there because of the reactions inside and this will be nominal. This particular heat PEA membrane cells. So this is how the oxygen and hydrogen goes into the system. The electrons will be separated out, and they cannot flow through this proton exchange membrane. So that's why they will be flowing through this particular alternative route, and then it is again getting clubbed together and going as an exhaust. Exhaust is nothing but the water vapor is going to be. And these can be very modular type of things, fuel cells. You want to increase the capacity, the number of stacks you are going to increase in series and parallel, and accordingly you can have the connection. Okay. Similar to the solar PV what we have now, it is also very easier thing to do nowadays. A lot of people are coming up with startups as well as the entrepreneurs, those who will be entering into the business of solar rooftop consultancy and rooftop installation industries, manufacturers. Yeah. So this has given a lot of edge for the people to become entrepreneurs and business. And what is a hydrogen fuel cell? Usually, the electricity will be generated. There will be main components, as you have seen already in the picture here. So the fuel, hydrogen and oxygen is the oxidant, and proton exchange memory will act as an electrolyte and emit water as the exhaust. So they will be working here, how they work here. So that also, I think all of you are familiar, and from the picture also you got aware of that. The hydrogen gas is entering here and will be going out, and this polymer electrolyte membrane, which allows only the positively charged ions to pass through it and to the cathode, and the negatively charged ions must travel to the external route and through this particular route, and which will be creating an electrical current. Okay. So that is a simple sort of understanding about fuel cells. So this is also the sort of the reduction oxidation and reduction cathode anode, what is materials you have, and what is the equation you will be going to get, how much potential or EMF, electromotive force we will be going to generate it. Yeah, E cell, that is 0.68 volts, it can be generated. So accordingly, you have to add up the number of cells in series and parallel to the required capacity to achieve. Okay, if you are going to have 12 volts, then connect all these things in series and achieve 12 volts. Then you try to increase the amperage and put it similar type of stacks in parallel. Then connect it. And there are various types of fuel cells. It is not one. The simplest one only I have discussed that PEMFC and phosphoric acid, atmospheric, molten carbonate, solid oxide fuel cells. All these things are there, and the range of temperatures they are producing while doing this particular reaction, that is also given here, and that's why I told you SOFC is one of the highest heat generator fuel cell. So that's why with that combination of this fuel cell, you can have a combined cycle with the gas turbine. So those things are possible. PEMFC is very simplest one. So that's why this is the preferred one for the particular automobiles, etc. So these are all just to give the information and efficiency ranges, which is going up to 50 to 70 and all, like 35 to 60%. And air also can be supplied and oxygen. So these are the general, to give the general idea about the efficiency and uses of hydrogen fuel cells. As I told you, the buses and trucks, etc., the vehicles, two-wheelers, and already in rockets and a lot of other places like marine and remote places where the things are working and military technologies, etc., where we will be going to have this particular fuel cell technology and small hydrogen cylinder and then fuel cell which we provide. So anywhere we can produce the electricity. So advantage is high electrical efficiency that is not limited by Carnot efficiency. And no harmful emissions, NOx, SOx, particulates. As I told you already, only water vapor is going to come out and can operate with wide range of fuels from pure hydrogen to coal gas with suitable reforming. Very, very quiet operation, no noise, and no moving parts, and less maintenance and more reliability. And potential for cogeneration and hybrid power generation with high energy utilization efficiency and modular construction that gives you a lot of ease in expansion of these plants. And 3-in-1 device, energy efficient, environment friendly, and fuel flexible. Fuel flexible, why they are telling is, as we show different types of cells. Some of these fuel cells, you are feeding other than hydrogen, other combustible gas is having more content of hydrogen in that. So it will take. The only thing is a little bit of compromise in efficiency will be there, and the way it will react inside because of that the heat energy development, heat development will be there. Okay, so that is the thing. And problems regarding hydrogen fuel cells, lack of hydrogen infrastructure. At present, if you see, that is one of the major problems. Infrastructure to production of hydrogen as well as storage of hydrogen. Okay, we all feel now the hydrogen is a very, very dangerous if you get exploded or something like that. So, a lot of safety norms we have to follow, and we have to create a lot of better systems for the storing of that and all. So that is lacking. Need for refueling stations. That is also now EV electric recharge stations are coming up in a big way in India. And similarly, later on, the other next time, after 10 years or so, then again we will have a try of having hydrogen filling stations. That is the future. At present in India, we have only one of the hydrogen filling stations is there in Gorakhpur, IOC, and Corporation. So hydrogen filling station is there. And similar stations we have to spread over the country. And when these vehicles will come up, the Hyundai is going to come up with fuel cell car in Indian market. Cost of hydrogen fuel cells, because earlier it is the cost and gradually it is reducing also. Okay. And carbon cost production, hydrogen. Problems with hydrogen fuel cell car, shortage 260 miles, but people are now telling about the almost like 350, 400. They are slowly, gradually increasing these capacities. So one method I already told you that by hybriding the solar and wind, continuously you will get the electricity and use it in electrolyte, the excess power, which you cannot able to store it or you cannot able to feed it to the grid. And that simple process is electrolyte process, water electrolysis, splitting water using electricity. And that is one method, but we cannot completely rely on this. At the same time, we have to think about the various other methods, production options. There are several processes like thermal, electrolytic, and photolytic processes. Okay. And in this, one of the methods we will also again try to discuss thermal related. So the hydrogen production options, we have several options. As I told you, coal gasification, no carbon capture, liquid reforming, biogasification, biomass, water electrolysis, the solar route. That is what I am telling here. I am clubbing this water electrolysis with wind also. So wherever the plants are separate, solar and wind, and both the places we can have water electrolysis process and high temperature water electrolysis. That means, in short, for hydrogen filling stations, behind that you may be having this type of solar PV parks or something like that, and you continuously can have the electricity in the daytime and during that time it will convert that into hydrogen. It will be storing it, and whole day the electricity, the hydrogen cylinders are available. You can able to recharge, refuel these vehicles. So, and also these cylinders can be supplied to the domestic applications, homes, wherever they have the fuel cell packs with them. They can simply our LPG cylinders, what we are replacing for the cooking applications. Similar way, people can be doing this. But these things are all going to happen maybe by 2050. So the current technologies in detail, if you see the thermal processes, one of the easiest thing I can explain that is the solar thermal. Already we have seen earlier the type of collectors, concentrators. By using those things, can we produce hydrogen? Similarly, electrolytic and electrolytic processes. So hydrogen production methods. One of the method we are going to see the thermal route, solar thermal route. That is what the solar zinc production. Okay, and the electrolysis of water is no need to see. That is a normal, simple process by supplying electricity. And the CNG and the other gases, biogas, which is having methane, rich and all. These gases also, if you do the reformation and get the hydrogen, those processes are more chemical related aspects are involved in that. People are working on these things also. Whichever comes out to be a meritorious candidate, producing hydrogen and at less cost, will be the process going to be established and rule the market. As I told you, the integration of renewables for the hydrogen production, like windmills and solar, etc., and similarly, micro hydro turbines are there, where it is going to be a small water streams. Where can you tap this by using a pelting wheel or any other type of simple turbines, etc. So those things can be clubbed together, and that can be used for hydrogen production. And that hydrogen can be given to these things, and it can be stored here, and it can be a standalone operations also possible because of this. And one side the electrolysis process will be going on, and the other side the fuel cell will be supplied with this side hydrogen and oxygen, and the cars can be run, and the washing machine can be run, the system can be run like this. So these are the things we can, by integrating, we can have. And simply to give some idea about the storage also, as I told you, you can compress that and put it in cylinders. And similarly, you can make it liquefaction, you can do, and liquid hydrogen, you can store it. And similarly, the metal hydrates, the porous material matrix metal hydrates, which is kept inside, and when you pass on this hydrogen to that, it is having a absorbing capacity, and it will retain the hydrogen in the matrix pores, and that will be released as and when it is required. That type of storage is also possible through metal hydrate systems. And this is what earlier also we have seen. So you can go for the combined cycle, and this is what we are talking. Initially, that diagram has shown you, and but it is supposed to be hydrogen based, so that's why it is appropriate to put it here. Okay, so that's why once again I'm just displaying it. I hope you understand the whole idea. And the other way of doing the hydrogen production, that is solar zinc method, I am talking about the solar chemical production, because it is also purely dependent on the solar energy. So that's why it is a good thing for Indian conditions one can apply. Only thing is the production of hydrogen is a little bit smaller in quantity. That's why people not look at it as an economical option, and that's why it's not picked up much. But this is one of the process, so one can know about. So in this process, briefly I can explain with the help of this picture. And zinc oxide powder which is passed through reactor. ZNO, which is available, and nitrogen. So that's powder if you are sending it. This is created, and the powder dissociates into zinc and oxygen. Apply heat to that, and some water also putting it, and ZN. So the zinc reacts with water from hydrogen and solid zinc oxide, and this forms the ZN. Again, whatever is available to water will react with that water, and it releases hydrogen. That is the beauty of this particular reaction, and hydrogen to be purified and collected and kept it stored in the cylinder. Okay. The solar react heated up to about 900 centigrade. That is one of the catch you have here. So, are we going to get this type of temperatures? Okay, is it possible? At a very highly concentrated, like earlier I told you, solar towers which are there, and all the heliostats are concentrated. In such type of systems, only you are going to get the very, very high temperatures because of the concentration. So that's why. So the formation of the thing for this particular dissociation process is there, and this particular Zn, 2Zn plus O2 reaction which is shown here, so that has to be happen at a very high temperature. So that's why this has to be done with some external source or very highly solar concentration, etc. And once you make the zinc, okay, the zinc has to be going to the site where you are going to produce the hydrogen. There you can have a smaller solar dish collectors, etc., which can easily generate some 300 and 350 degrees centigrade temperature, and those are sufficient where you can mix the zinc and water. So that high temperature of 300 and 350 degrees centigrade, the hydrogen will be produced, and continuously at the site will be storing the hydrogen. Okay. So it is a recyclable process. Once it becomes ZNO, then it has to be recycled, and it has to go to high temperature source where the highly solar concentrator can produce the high temperature. It's available. Then you can again this dissociation takes place, separation process. So this will be going on like a continuous cycle. There will be some attrition during this recycling process. Because of that, some makeup zinc oxide maybe zinc may be required for the design system. But otherwise, it is more or less simply a recyclable process, and continuously can produce this. This is what I told you. The high temperatures, to achieve these type of temperatures, you can type of heliostat and tower mechanism, deflection system, if you have. So concentrate all these things onto this, and get good high temperatures, and which will be okay for making this particular dissociation process of ZNO. And this is what I have explained here, almost like so even 1200 degrees centigrade and more than that, if you have less efficiency, the ZNO breaks into ZN and oxygen in the process. And also these 350 degrees and all you have to have in the second stage where you have been having production of hydrogen is going to happen. So this is the process I explained about, and those chemical cycle uses solar energy to make hydrogen. So this is also feasible one. Solar energy can be concentrated by mirrors and special lenses to generate temperatures close to 2000. That is what the requirement is. This temperature can be used to trigger a series of chemical reactions, split water molecules to produce hydrogen without generating any harmful emissions. So that's also another way of producing hydrogen. And a lot of R&D challenges in the sense there are various methods of producing hydrogen is available. And out of that, everybody has to work on so many things, and so many groups are working. And finally, the thing is the economical use of the process is more economical and more safe and more easily practicable, and that can be adopted. So till then, the people has to go on working with these technologies and try to produce the hydrogen efficiently, because hydrogen is going to be the future fuel, as all of you know, okay, future energy. So, and also it is very clean and a sustainable way. If the methods are established, it will also become sustainable, because the water is the source where you are splitting it and getting hydrogen out of that. And again, you are using it in the fuel cell, and again, you are making it to get together and form water. So it's a very beautiful process you can think about. So a lot of difficulties and hindrances are there in this, but this is the future. So one has to work on these things. Similarly, the water electrolysis process, only the splitting electricity, water using electricity. So there is no here. And the renewable power water electrolysis process, that is what I'm talking about, wind and solar. The central or semi-central facilities could overcome these challenges. These facilities may take advantage of technology advances or receive cost breaks from the utility by using off-peak power. The power plants, etc., if you see, nowadays a lot of grid feeding is there because of the solar and wind. So you have to match the peak loads, etc. So off-peak loads, when it is there, and still the wind and solar will be supposed producing electricity. So then where it will be going? So you have to identify, and you have to use it for what electrolysis process centrally, and then you have to store these. So this is what the windmill, that electricity, if you are feeding it to grid, and then you are not feeding it to grid, then you do electrolysis, compress it, so you can use it later to fuel cell route. Okay. So there are other methods also there. They are not much explored. Even microbiological things also, some of the bacteria is also working to produce microorganisms, also working green algae, etc. So for producing the electricity, hydrogen, but these are the processes has to be get established and still on a very low phase, and the hydrogen production itself is also at a very low level. Okay. So this is what the future expectations, and the Hyundai is also front running with fuel cell mobilities vehicles. Abroad, they are already launched and a lot of trials have been done. And in future, in India also, we'll be going to have this by 2050 type of refueling stations. And shortly, we'll be looking at the charging stations at every each of the petrol pumps which are present at now. So similarly, there will be charging stations. There will be again hydrogen stations also going to come up. Okay. So this is what the hybriding and facilitating the production of hydrogen, that is what I wanted to convey to all of you. Thank you very much for your patience listening. I would like to stop here and thank the organizers once again. Okay, Jani sir. Yeah.
Dahod, I am thankful to the Dr. P V Ramana sir for providing very advanced information on the topic hybrid power generation system. Our participants get a lot more knowledge with regarding to the recent trends in the hybrid power generation. Thank you, sir, for delivering excellent knowledge over to the hybrid power generation systems. Thank you, sir.
Thank you very much, all of you.
Thank you, sir.
Okay, sir.
Any participant or
any queries? Any queries are there? You can reach me. You can reach me to this email address is also given, and you can discuss. Yeah. Okay, sir. We will close here.
Okay. Now, you can left, sir. Yes, for no concern. Thank you for your time and effort in educating us, sir. Thank you.
Yes, thank you very much for giving me this opportunity. Thank you all the conveyors.
Okay.
Thank you very much, sir.
Yeah.
Now, participant, we stay in the meeting. We will have to discuss some short note over to the national education policy. So far teachers as well as student may concern